There's another way to solve this equation by completing the square. Do you remember the binomial formula that we had? So if we look at the sum x squared plus px, we can expand it to a full quadratic equation and bring it to this form. So how we do it? First we take x squared plus px. So to make this expression look like this, we do the following trick. First of all, so we leave x squared as is, but then we can divide and multiply px to the same number. You know 2 divided by 2 is 1. So px is still the same if we multiply it to this fraction, which is equals to 1. Plus, we can add p divided by 2 squared minus p divided by 2 squared. So we added and subtracted the same number, and thus this expression will be equivalent to this expression. I hope it's clear here, because now if you look closely, our expression kind of look like this here. Do we have a square? Yes, so let me change the color. Do we have 2ab? Yes, we have 2, and this will be ab, right? And do we have b square? Yes, we have it right here. So we can rewrite it as the following: x plus p divided by 2 squared, right? So we completed the square here, and the rest we will just move it here, and it will be minus p divided by 2 squared. So then if we take this expression here and move it back here, it will look like this. So this one is square, and then subtracted q from both sides, and q moved here with a minus sign, and p divided by q squared to the other side, and we also change the sign, and we get this kind of formula. So if we solve an example, x squared plus 8x plus 7 equals to 0. So here is a shortcut for our completing the square. We don't have to do all this that we did before to get it. And by using the shortcut, we can rewrite it as following: x plus 8 divided by 2 squared equals to minus q, which is minus 7, plus 8 divided by 2 squared. And we can also rewrite it as x plus 4 squared. Here will be minus 7 plus 16, and we will get in the end x plus 4 squared equal to 9. So if x plus 4 squared equals to 9, it means that x plus 4 equals to square root plus minus square root of 9. Then minus 4, we move 4 to the other side, and it becomes minus 4, and Square root of 9 is 3, if you remember. So minus 4 plus 3, which is minus 1. And x2 will be minus 4 minus 3, which is minus 7. So the solution set will be minus 1 and minus 7 for our quadratic equation. I mean, this looks very complicated at the beginning, but if you want to have a shortcut and you just memorize this formula here, you can solve it really fast without finding any discriminant and remembering all the PQ formulas. To remember it, you just need to train a little bit, get the skill, and by looking at the equation, you already could easily find the solution. One more way to solve a quadratic equation is by using Vieta's formula. The relationship between coefficients p and q and the solution x1 and x2 can be described via Vieta's formula, which is following. So relationship between p and q and the roots, which are x1 and x2, could be described via this formula. Important remark: if a quadratic equation only has one solution, which is x1, then we let x1 be equal to x2. So if we have the following quadratic equation, which is x squared plus 4x plus 4 equals to 0. So we need to find out minus p and q of this equation. So minus p will be, if p is 4, then minus p will be minus 4. And q is equals to 4 here. Since q is positive, it means that either both x1 and x2 are positive, or x1 and x2 both are negative. Because as you may see here above, this formula here means that by multiplying x1 by x2, you get 4. And at the same time, we know that x1 plus x2 will equal to minus 4. So what kind of combination of two numbers can give us in sum minus 4, and at the same time, if we multiply them, it will give us 4? You can pause the video now and think about it. If we proceed, for example, there's different combinations that you can get 4 here, and both should be negative. And it could be minus 2 or minus 1 minus 4. But if you look at the formula above, if we take minus 1 minus 4, their sum will give us minus 5. But if we take minus 2, then their sum gives us minus 4. Then we can proceed with that. So minus p is minus 2 plus minus 2 is equal to minus 4, which is true in our case. And for q, we have again minus 2 and minus 2 will equal to 4. It means that our equation has only one solution, which is minus 2. So solution set for our equation will be minus 2. Same as the previous method, completion that square, Vieta formula really requires some skills, and you have to try it many times. And when you practice this enough, you can find out roots just by looking at the equation. And one more thing to mention is the equation should be in the normal form. So for more complicated equations, it's better just to use ABC formula. So these formulas you can use if you want to save time. All right. Okay, next method is factoring. Factoring is also one method to solve the quadratic equations. So before we start, Let's say that we have two real numbers, which is a and b, and their product is equal to 0. How we can get 0? It means that either a or b is equal to 0. And so if a is equal to 0, it means that b is non-zero. And vice versa. If b is equal to 0, then a is non-zero. This rule is called null product rule. So we will base factoring method based on this rule. So let's apply this rule, for example, to the following. So we have an equation which is x squared minus 5x equals to 0. If we want to simplify it, we can also rewrite it as x multiplied to x minus 5. So this means that we have two options from here. If you remember null product rule, it means that either x is equals to 0 or x minus 5 is equals to 0. This method is useful in writing products at simpler terms in order to calculate the roots of larger expression. Then we can also write it that x is equals to 5. The transformation of a term into a product form is called factoring the term. Factors of the form of x minus a, where a is a real number, are called linear factors. So this method is useful in writing products as simple terms when you have calculate roots of larger expression. For example, if we have this expression here, which doesn't seem as a quadratic expression to us, we can simplify it by writing it as a factor and putting x squared outside of this expression and get this one. This will mean that either x squared is 0 or this expression here is equals to 0. And further, we can solve it through any of the three methods that we saw before and find the roots. So let's calculate the discriminant with the formula. So b divided by 2 squared minus q will be 2 divided by 2 squared minus 3, which is 1 minus 3, and it is minus 2. So you remember, if we have discriminant smaller than 0, then we have no roots. So it means that we don't have roots here. Then the only answer we get will be x equals to 0. So then the solution set of this expression will be 0. Another way we can use factoring is, if you remember the binomial formula, a squared minus b squared. For example, if we have equation x squared minus 9, then we can rewrite it as x plus 3 multiplied to x minus 3. Then we will get either x plus 3 is equals to 0 or x minus 3